Thanks, Brendan, and thanks everyone for coming, even though it's very early on a Sunday morning. So today, actually, my talk is going to be a little bit about a lot of the things that I do. So you might come away from this thinking I'm a totally random, crazy person, even in a data science context, if you haven't already been convinced of that from Brendan's introduction. So I'm actually going to be talking about one of the biggest problems that we have in data science, and it is basically to recruit data scientists, and it's being hired as data scientists from what I've heard of conversations that I've had today. My slides are sort of attached to that link, and I'll show that at the end if people want them. But basically, I wanted to contextualize some of this in terms of the way that some of the sort of jokey, funny ways that we think about the war on talent and the sort of the comical ways that we think about it. And so, you know, I Am Recruiter is one of my really, loves of life. And I love this because we've all seen examples of this kind of behavior in jobs. And then we see from especially founders of startups with posts about how the war on talent, the war for talent is real. And when you think about it from the other side of it, and we're very sort of candidate focused, even though we sell to companies, it's really very much a war on talent. And so I think the I Am Developer post from this sort of Twitter thing sort of gives you a bit of context of that, is that this trying to manage all of the many types of requirements that people and companies are frequently looking for within budgets is a very difficult process, and calibrating those sorts of requirements is actually very difficult. And so that's something that we think about a lot at TapRecruit. So the starting point of this is we sort of come from a point that we think it's very important what companies say to candidates, and that actually really strongly influences the candidate pools and the likelihood of success in those processes. And these processes are long, they're expensive, and they're fraught with all sorts of in terms of inconsistencies, they're not robust or reproducible. And so our goal is to bring data science and decision science and very complex NLP tools into that process and really understand how we can make these processes a lot more reproducible. And so the research that I do, the group that I run, sort of takes this on in two different ways. The first is from a decision science standpoint, which is this question of this, well, how do candidates make decisions about which jobs to apply to? And from the one hand, a lot of companies think that because of things like one-click apply, things like ZipRecruiter have made it and LinkedIn have made it very easy for candidates to apply to jobs. And so the assumption there is that candidates apply to any job that they're remotely qualified for. But that's not actually what we see, and I'm going to be talking a bit about that in a couple of slides when we talk about some of these vignettes. On the other side of things, what we think about is how do hiring teams make decisions about what a candidate's qualifications are and how much do they match for the job. And so you can imagine that comes in a whole range of different things. These are some toy examples of equations that might sort of go into that process. And from the NLP and data science side, one of the big questions that I'm very interested in, and that is sort of an ongoing area of research, are like, what are the distinguishing characteristics of what is a successful resume or a successful job description or a successful promotion package? And the last part of this is we sort of look at language and skills, and what I'm going to be talking about at the end really quickly, hopefully, are skills that are sort of very core data science skills and how they're spreading to other industries. And so we do a lot of skills mapping because we have to do a lot of semantic analysis to understand how those skills are expressed in jobs and then translate them into sort of large-scale trends that we're looking at. How does it compare to in different industries or different company types? How do Fortune 500 companies talk about data science skills versus, for example, unicorns or startups? And how does location factor into that? So you can imagine that coastal companies talk very differently to companies in the Midwest about these sorts of skills. And so these are the sort of big picture questions that I deal with on a daily basis. So we are actually not a research company. We are a commercial company, and we basically produce software products that help use NLP to basically convert unstructured career documents. So these are primarily natural language documents into structured data. And so I just wanted to give you a bit of a context of how we think about the world and how we connect all of these insights and what's critical to this, so that you can have some context for some of the research that I'm going to be presenting. So the first thing is a smart editor for job descriptions, and these are basically, and I'm going to show you in a couple of slides what that looks like, but essentially if someone's typing out a job description, we start making suggestions based on the language. So whether you're writing language that is very unwelcoming or very full of corporate cliches or grammatically incorrect or gendered on one side, and the content. So things like, are you asking for too many skills or requirements, and given the talent market that you're sort of addressing. The second part of it is in terms of pipeline health monitoring. So that's part of this whole idea of evidence-based recruiting. So what we know is we have a whole lot of training data that we know, a job like this should get this many candidates, this many female candidates in general, and how are you going on those metrics? Are you getting them fast enough? Are you having issues getting your job description out there? Where are the sort of pipeline health issues? And also to analyze, as people go through the process, what is your typical qualification rate? So like, are you getting a lot of qualified candidates, or are you not getting enough qualified candidates? And how can we help you understand that process a little bit better? Or whether that certain stages in your pipeline process, so when I'm talking about a recruiting pipeline, we're going from everything from putting out a job to evaluating the candidates, and then you put them through interviews, and then you put them through technical interviews. Are there any steps of that process that seem to be taking a long time or causing candidates to fall out of the process disproportionately? So we sort of provide a lot of analytics of companies that we help. And then the last thing is salary estimation. And this is something that is primarily we're using from a company perspective. So we're not helping candidates understand salaries better. What we're trying to do is to be like, tell companies, look, this kind of combination of skills that you're asking for, this unicorn that you're asking for is going to cost you $350,000 a year. That's the expected salary for someone like this, and it's very rare, and it'll probably take you 6 months. Maybe if we drop some of these requirements, you could probably get there a little bit faster. And so this is just, again, a little bit of a nudge to get people to sort of correctly calibrated job descriptions. And actually it can work the other way. So it's also an idea, the other sort of side of this is, frequently you'll see job descriptions that are so vague that you like, is this an executive assistant role, or is this like a sort of very senior role? And so by estimating that salary, they can be like, actually, no, this is a much more senior role. Let's add some qualifications to get it up to the right sort of level that it should be. So a lot of our stuff is not too little, not too much, just getting the job calibrated to the right context. And so this is sort of how it looks from a interaction standpoint. And what I want to highlight here is that we have a lot of language highlights in here where we identify content that's missing, perks and equal opportunity statements, things that are actually very important for candidates, which I'm going to show you in a couple of seconds, and also things like qualifications. So we understand, we've built very custom dependency parsers for understanding job language and to be able to extract important skills. And so we know that, if this is a senior finance role, analyst role, we can compare it to other jobs in the same location. We can also understand what are the requirements that you're asking for and how do they differ from other jobs in the location. So that sort of contextualizes some of the problems. So in job descriptions and in career language, a lot of this natural language processing and really skills, generating a skills taxonomy has been at the level of a title. And this is a very fraught process. So as this example shows, two jobs that have the same title can be very, very different. But a lot of the career tools that we use sort of match on title, and they match salaries on title, and everything gets tied on title because it's assumed that that's the major mechanism that's a key differentiator. But what we find is actually it's more often wrong than right, and so it doesn't match skills and experience and responsibilities. And the other part of what we do, and because we're able to extract the skills and the requirements from these roles, what this allows us to do is to find similar jobs that have very different titles that would never have been picked up in any other context. And this allows us to do some very rich analysis of the jobs and also to sort of look at the language. So here I showed, SQL versus relational database. We actually have mechanisms of mapping semantically different expressions of the same skill set to each other, which I think is really very powerful in terms of what we're able to do. So I work primarily on the research side of this, but these are tools that I get to use on my daily basis to be able to aggregate similar jobs and to understand what's the impact of a title, for example, or what's the impact of the way that you describe certain types of skill sets. And so this is the last slide that I'm going to give you, and it's a background of the kind of data that I deal with on a day-to-day basis. We have 15 million job descriptions and a whole lot of company-verified salaries. And as a side note, and this is almost its own talk of itself, we have candidate job search data because for 3 years we were a job search site for candidates, and we sort of pivoted to becoming a B2B offering, and so we've always kept that up, and so that's actually given us rich insights, and I'm going to show you a little bit about that later. From a classification standpoint, and I'll talk a little bit more classification at the end of my talk, we look at a lot of job categories, we have a lot of different characteristics, and these are things like responsibility, skills, and education. And we also are an opinionated editor. So we give a lot of different unique sort of highlights, and we tell people, no, you should write it this way, based on the research that we've found. And so this is actually, these sort of numbers sort of give us the core of a job, and we're able to make very specific decisions. So the core of my talk is going to be talking about 3 key hiring heuristics, so things that we tend to take for granted, and I'm going to debunk them. That should not be a surprise. And so the first one that I'm going to talk about is job titles. So there's a lot of different ideas about what a job title is and what it means. To some people, it's what's on your business card. To some people, it's what's in your email signature or your LinkedIn profile. But what I tend to argue and what we tell companies is, job titles are actually really critical for candidates finding jobs when they're looking for a job. That should be the single most important thing that they think about. And it seems very obvious, but actually it has very dramatic implications in terms of the candidate pools that you get from these. So the context that I'm going to talk about is the idea of title inflation. And so we've seen, this is an analysis, and I'm going to show you this little vignette, of jobs that are typically require 2 to 4 years worth of experience. So no more than 4 years worth of experience. And in data science, what we've seen is this massive growth of senior data roles that are called senior data scientists for people who don't have a ton of experience. And we're seeing this title creep, this sort of inflation of titles coming earlier and earlier in the pipeline. So actually, I've actually seen roles that are probably what you would call an entry level, or what we call an entry level role. So people with no experience, we're starting to see 2 or 3%, which are called senior data scientist roles, right? We don't see the same in every industry. Certainly in software engineering, we haven't seen as much title creep. So this is something that's very big in data science. There's a lot of probably reasons for it. But I think the predominant reason is that people think that, normally you have a normal set of applicants, and we have a data science role, which is relatively junior, and you get a large applicant pool, and then you put them through the hoops and the hoops that you want them to jump through, and you end up with a few qualified candidates. But the idea behind this and the intuition behind this is that if you put a senior filter on, you call a role a senior data scientist role, you probably attract a slightly smaller candidate pool, but you get more qualified candidates. So this is a typical signal to noise ratio kind of optimization that people think is happening. And one of the first things I did when I first joined the company was like, is this really true? Because I'm very curious, because I would never, even after 4 years worth of experience, have applied to a senior data scientist role, and I wasn't sure that that was the case for everyone. And so what we find is, when we looked, so the context of this is, in all of the next couple of slides, we took jobs that were similarly qualified over the last couple of years, and we had one batch which were like data scientist roles, and we had paired jobs which were called senior data scientist roles. And I could probably show you a few examples because quite a few companies advertise both, and we're sort of doing an A/B test at the time, I think. And those basically showed what I'm going to show you. So these were all in tier 1 cities. So these are New York, San Francisco, and Los Angeles and DC to a certain extent. And so we restricted on sort of similar skill sets. So these are highly controlled set of jobs basically that we looked at the outcomes for. And so obviously when you add senior to the role for the same kind of requirements, what we see is that the number of total applicants goes down, which is what we would expect. The actual average number of qualified applicants is also It's slightly more actually under the data scientist role. So I don't imagine that most companies have looked at all 110 applications, but they say they have. And so we have an actual increase in the number of qualified roles. And what I found actually the most compelling from this process is the last thing that we look at is how successful is this process. And so typically for most data scientist roles, junior data scientist roles, which I'll call them that, it's about 60 to 70% of roles are filled or completed. There's a third of them that are typically not filled. They typically just, nothing happens and then maybe the whole process starts again. And what we find is actually the data scientist roles are much more likely to be filled than the senior data scientist roles. So the chance of success at the end of this couple of month process is double, which is, I think, quite striking. It's telling us something about the number of applicants, that we're getting fewer qualified applicants, and that this is, but based on the qualified applicants, the chance of success is actually quite low. So as a scientist from a previous life, I'm very interested in mechanisms. And so I was very curious, what is causing this big difference between data scientists and senior data scientists? And so one of the theories we had was this idea of the confidence gap. And because, I reflected, I probably wouldn't apply to it. And I asked a bunch of friends and they said, yeah, I probably wouldn't either. And the confidence gap is this idea that people of different populations, and this is primarily thought of in gendered terms, but I think we're starting to come to an understanding that it's a little bit more complex than that, but that, that there's a group of people that will only apply to a job if they meet every single requirement, and then there's other sets of people that might not, even if they don't meet 50% of the requirements, they'll still apply. And so we thought, okay, well, maybe this is like making people feel like they have to, they haven't met all of the requirements. So just that one single name, like it's not even a requirement issue, it's the fact that this is a senior role. So actually what we found was, because we were able to look at candidate search data and the candidate behavioral data when they look at it, we found that actually it's not all explained by the confidence gap. One part of it is, and I'm going to talk a little bit more about the confidence gap in the next slide, but the actually interesting thing was that this is very obvious for anyone who works in information extraction. Firstly, senior data scientist is a very rare search term. It's not very typical. So if I were a candidate right now looking for a role and hoping that I would turn my advice around, because I'm telling companies don't write senior if it's not a senior role. Well, if you're a candidate, you're looking for the arbitrage opportunity, maybe you should apply to these senior data scientist roles that are quite junior, because they're not getting that many applicants, you're more likely to go through the process. But firstly, it's a very rare search term. The second is, actually from Search 101, if you think about search algorithms, when you start adding unnecessary terms to the process, it doesn't rank as highly as the roles that are called data scientist. And so I think this is something that we definitely have seen, that you will see a few senior data scientist roles come up in your search, but it's not nearly as much. And so what we have been able to do from extracting the number of candidate click-throughs and the number of candidate views is to sort of attribute some of this difference to, about half of this difference actually, to a visibility gap. And that's actually something that companies should think about, and that's something that I think has a broader lesson to be learned. If I was to write a senior data scientist Washington, DC, that's also going to do worse in search results than it will if it's in the title, right? Rather than it would if it was in any other part of the job description. And so those are things that companies should think about, and it's something that's an arbitrage opportunity actually for candidates. If you want to find the jobs that are less likely to come up on search, maybe you want to add some random words in there and take a look at it. So the second part of what I was talking about and alluding to was this idea of the confidence gap. And so we went back and looked at the number of female candidates, and what we see is not only in the number of female candidates, but the proportion of female candidates is much lower with the senior data scientist role, and this is pretty reproducible across it. So this is just a representative example. What we also see is that the number of qualified female candidates is lower. And the proportion of hiring a female candidate also goes down. So as this process goes along, but when you start off with a low base, you end up with much lower, versus on the data scientist role, we end up holding the proportion sort of across the board. So it sort of ends up with a more representative chance. We don't usually try and optimize for like and 100% chance of a female hire. What we want to see is something that more or less represents what you get in is what you get out. And so this is, again, another sort of example. We've seen this also with the instances that we have EEOC data with minority candidates as well, but it's not as complete a picture in this case because we don't have a ton of that data. So the second part of what I wanted to talk about is money. And obviously, data scientists are all about the money because it's the most glamorous, most highly paid job ever. But I'm joking. From the standpoint of a lot of recruiters, one of the questions that gets often asked is, in the States, and this is something that, from my background in Australia, salaries are frequently part of job descriptions, or salary ranges are included as part of job descriptions. But one of the things that I was very curious about is how do companies communicate whether they're a very generous environment or not in the context of job descriptions when salaries are very rarely, salary ranges are very rarely included. And so this is something that I think from the standpoint of companies frequently think of how candidates respond most to, like a generous company, and so that's the end of it. And so this is sort of contextualizes some of the stuff that I'm going to talk about in the next couple of slides. So I don't need to explain any of this. I'm actually going to talk a little bit about competitive salary in the next slide. But it's sort of a bit about the perks and benefits, because perks and benefits are one of those soft ways that companies can communicate culture as well as their generosity, and also salary ranges can also be sort of communicated through that process. So one of the things that we saw when I first started doing this work a couple of years ago was that we started seeing this thing called competitive salary come up in a lot of different job descriptions. And so initially it was very, very low. And I remember in 2017 when I first started looking at it, it's sort of spiking. And so it kind of got my interest. And it was something that was talked about a lot in startups. So startups would mention competitive salary because it was one of, they couldn't really talk about, they'd talk about stock benefits and stock options and things like that. And then actually now when we're talking about this massive increase in competitive salary, it's not just startups that are talking about it, it's Fortune 500 companies that are talking about it. It's actually big established companies that have now adopted it as part of their lexicon of job descriptions. And so obviously the first thing as a scientist I had to do was check, have salaries become more competitive? And there is no axes on this because they really haven't become more competitive if you look at BLS data or any other form of data by city or anything else. And so real salaries have really remained steady. But one thing that was very interesting to us is when we looked at the outcomes data, when you mention competitive salary, it attracts a lot fewer candidates, and these jobs take a lot longer to fill, and they're also less successful. So what's really nice is that we're dealing with humans who are making mistakes all the time. And some jobs, we have a lot of paired jobs from this because sometimes companies mention competitive salary, but it's not part of their templates to mention competitive salary. So we have a really robust sort of understanding of this. And so from a company standpoint, it was very strange to them when we were like, okay, you shouldn't write competitive salary. And they're like, no, but it means something good. It's it's one of those good things that people signal. But actually, from a candidate standpoint, and I think if you think about it from a candidate standpoint, you're like, actually, that sounds dodgy. That sounds like a company that's probably not going to pay me very well. And so they're trying to signal that they're not going to pay me very well. And so this disconnect between what a company thinks that they're doing in that they're being very pleasant and really good, between how candidates interpreting that is sort of the core of what I really study and what I think is really interesting. And the basis of our sort of software is to get them to the same page. So the second part of this is, perks and benefits are really critical. And so the other way this plays out is in terms of this disconnect, again, between how candidates actually search for a job, which is on mobile, which is on, apps, through LinkedIn, through Indeed, through those sort of third-party those third-party software search platforms, versus how companies think candidates search for jobs, which is they think they go to their website and you're sitting there and stalking them and looking at all their amazing perks and benefits before you decide to apply to a job. And so what is really interesting is that we know that from a whole range of research, not only our studies but others, that perks and benefits are really critical factors in deciding on jobs. It might not even be the value of the perks and benefits. It could be the culture that it's actually transmitting to the candidates. But what's interesting is that very few companies mention perks and benefits in their job descriptions. So they have beautiful websites that are, associated with it. And that disconnect between what candidates do versus what companies expect them to do sort of creates a bit of a gulf. And so actually we've always seen that startups have generally have done a really good job in terms of mentioning perks and benefits, because they know that that's one of the few things, like, you don't know a startup. There are very few startups that you do know. So it's one of the ways that they can sort of get brand attention versus unicorns and Fortune 500s, which are actually increasingly mentioning perks and benefits, but not nearly as much. And so we wanted to drill down to see, okay, you mentioned perks and benefits, but which ones are actually really important for candidates? And so you've seen a plethora of these sorts of things in the Muse and various other sorts of business journals about, all of these amazing, unique perks and benefits that attract millennials and things like that. And what are the signaling impacts of that. But what we actually find is with millennials, with middle-aged workers, with all sorts of workers actually, it's really not the unusual perks and benefits that matter. It's the things like medical insurance, 401k, family leave. And actually the phrasing matters as well. So things like paid time off sort of signals a very generous company. It's something that actually candidates value. So we've asked them to put an actual dollar value on these things versus something like unlimited vacation. Unlimited vacation sort of came out a couple of years ago when Netflix first started introducing it, and it sort of spread throughout the valley. And a lot of companies have adopted that phrasing. And what that means to candidates, and we know now after a few years that actually the companies that offer unlimited vacation have very few, have workers that take a lot less vacation, and so it's not really worth what it is, but to a candidate it's actually worth negative dollars. So it's sort of one of those things that it sort of acts as a deterrent. But the phrasing actually is really critical, and there's a lot of different ways to express this and that express a different type of culture, and actually that's very important. So the last little sort of vignette that I want to talk about is diversity and how this idea that it can be hacked, because we all love to hack various things. And so the context of this that I'm going to talk about is the Rooney Rule, because it's something that's become widely adopted throughout tech and in a lot of different industries. So in 2003, the NFL adopted the Rooney Rule. Many of you might be familiar with it, but to those of you who aren't, it's basically an idea that when you interview for head coach positions, what happens is that you have at least one minority candidate. And this sort of came as a result of the fact that there were very few NFL head coaches that were of African American and Hispanic descent, given the huge number of especially African American players in the NFL. And it was very, very successful. It's so successful that the NFL has adopted the Rooney Rule in various other stages of the process, sort of trying to increase the number of female coaches through this process and like less senior coaches through this process. And so it's been very, very successful in the NFL. And that sort of caused it to, 13 years later, be adopted in big tech. And so, Facebook, Amazon, pretty much all of these big companies are using the idea of the Rooney Rule to deal with, board diversity and also diversity on a micro level. So by micro level, I mean all of the recruiting decisions that they're making on a frequently daily basis. The counter-argument to this sort of came from a study that was published in the Harvard Business Review, which I think is very interesting because it highlights this idea that having only one woman, and they also did the same for minority candidates, in a finalist pool actually they have a very low chance of being hired. And so it's almost actually no statistical, I think the title of the article was that they have no statistical chance of being hired. We haven't seen exactly this bear out, but there definitely is that sort of trend. And I think the other thing that's very important is that in terms of candidate backlash, that candidates are sort of interpreting this as a sort of a sham of a recruiting process. I love these two tech writers and amazing technologists, and I think they really do highlight the sort of the tension in the Rooney Rule on a sort of daily sort of recruiting process. So we went and tried to find things that actually cause reproducible, improvements in hiring, especially in tech roles. And I'm going to show you the example of data science roles because I think it was so compelling to us when we looked at it. And what we did was we looked at we tried to find attributes that were common to data science roles that were successful versus not. And one of the things we found was that it was kind of striking to me when I mapped it, when I looked at the distribution of the jobs, we looked at the number of candidates. That basically was a very clearly bimodal distribution. There was one that sort of centered or maximized at 40. So we have the things from like 20 to 40 candidates. And then we had the ones that were more than 80 candidates. And so these are sort of representative examples. What we found was a 40 candidate pool for like a junior data scientist role was really rather anemic. It got, as a proportion and as a raw number, much fewer female candidates. It got fewer qualified female candidates, and the chance of a female hire was very, very low, actually. What we found in contrast was having about 100 candidates, even if you didn't evaluate them all, was a much stronger pool. There's something about the health of that pool that is a very clear indicator, and the number of qualified female candidates and the chance of a qualified female hire was sort of stayed even. And so this is what we say, and our argument is generally the thing that is very common to all of this is a large candidate pool. Now, I get a lot of pushback from a lot of companies who are like, I don't want to have to screen through 1,000 candidates. It's very rare that anyone has to ever screen through 1,000 candidates. What we're talking about is a difference between 40 and 100, and it's also actually the difference between running a 40 candidate pool process 3 times, exhausting and getting really frustrated job seekers who are like, I keep applying to this job and they don't really look at me and they don't want to do anything, and it keeps coming up on my searches, versus a one-shot where in 3 months you can go through that whole process and actually finish it up and actually hopefully in 2 months or 1 month actually get through the process. So that's sort of the context of what we think about the world. So I'm going to just quickly wrap up this section of it that I talked about job title inflation. And from a candidate's perspective, that's sort of looking at job titles that are kind of unusual because they tend to impact the visibility and deal with confidence gaps. I also talked about how the factors that we typically think of being really what you'd call, they promote interesting ideas about, as in the, I'm blanking on the word, but it's the word that they're sort of signaling benefits in good ways are not as obvious as you think. And then this last idea that actually just artificially inserting people into your talent pipelines is a successful way to improve female hires. And what we find with sourcing when we look at the different types of sources that candidates come from, actually the most important thing in our books, and it's reproducible, is the representative candidate pools. Because again, these are contexts where you actually have a successful process. So very quickly, I'm just going to talk about the skills side of what I'm going to talk about. So just in terms of a quick vignette of this, because I've taken a little bit too much time. But the key question that we have here is this idea of how have data science skills changed over time? And we're not talking about a time of 10 years, we're talking about literally 3 years. And so how did we do this? So to make a very long story short, we used word embeddings, which are basically distributional models that express the relationship of words to their context. So that's how I'm going to really condense a very large body of research into this, because I want to get through and explain to you the context of this. So, these are some examples of phrases that we would typically find in job descriptions relating to Python. And when we do a low dimensional reduction of this sort of embedding, what we see is that, the words that are closest to it, we get some context. This is an unsupervised method, obviously, largely. So, we can get some context that Python is a bit like Java and C++, and it's probably a programming language. And if we add a broader context of other words, we can understand other sorts of topic areas, we can really get a sense of the other languages and how do languages fit in and sort of separate them through learning. And so this has been very powerful in terms of understanding entity relationships. And I'm going to just quickly go through this in terms of understanding hierarchies, comparatives, and superlatives. And, I think the biggest magic has been in this, woman to man and woman is to queen as man is to king, which is my inversion of what is typically thought of. But I think this raises, so to sort of these highly dimensional sort of embeddings have been very interesting from a lot of different perspectives, but how they've been able to draw sort of continuous learning from them is a huge open question. And so when I'm talking about connecting them over time, there's basically two mechanisms that you can do this. One of which is training a whole bunch of individual embeddings for different from different time points, and that requires you to use a lot of data, firstly, and it also requires you to align them, which you can do by hand. And what we did was we took, in 2017, there were a whole lot of papers that were talking about using time as a sort of latent variable, so we can then connect them over course, and we don't need to. It's basically one model to rule them all in some senses. And so I'm actually not going to talk about what the outputs of this are. Just by chance, because of some fun JSON rendering, we ended up with a small corpus and a large corpus. Actually, the small is a subset of the large corpus, and we're now obviously expanding this to a much larger corpus. We did this with all job types. We didn't restrict to just data science roles, because I wanted to see how data science skills are sort of infiltrating other sort of areas that we wouldn't normally think about. So that was sort of my intuition going into this. And what I think is really interesting about this is when you're generally training word embeddings, you typically take 300 dimension embedding and train it over time. And we sort of did this with a much smaller one, and it actually worked really well. So this was a very small number of documents over 3 years, and is also, even our large corpus is a very small number of documents over 3 years. And so what did this show? The first thing is that we saw that actually the output of this is the key drifting words. And one of the key drifting words is that MBAs and PhDs across all jobs, so remember this is all jobs, are falling. And so we looked at MBAs and PhDs. Obviously, MBAs don't play an important role in most data science roles yet. But we saw that actually the number of data science jobs that are requiring PhDs is actually dropping kind of significantly. So this is over the last 3 years, but especially from 2017 to 2018, we've seen a big drop. The second thing is in terms of skills that are showing significant shifts. We're seeing a huge increase in jobs that are requiring data viz skills especially. Power BI sort of started off of, as in this is a little artificial in terms of the plus 100% because it's starting off a kind of small base. One of the key words that came out of our analysis was Hadoop. It was actually probably in the top 5. It was kind of egregious how it came up. And obviously you can see that Spark has stayed steady. Hadoop has fallen a lot in terms of requirements of job descriptions, and that probably makes sense because it's so easy to set up AWS instances. I wouldn't know how to set up a Hadoop cluster, but these sorts of skills have become a lot more democratized in some senses as these things have developed. And lastly, in terms of, this was an obvious one. I was actually really happy to see Perl come out because I expected it to not be that critical, but it's one of those phrases that's comes out of a lot of job descriptions because you're talking about scripting languages that are important. But obviously Python has stayed steady, and actually I expected it to rise, but it didn't, and it was sort of it's an area of research that we're still looking at. So the last thing I wanted to talk about was this the large corpus. And so what we see is more semantic shifts with this, whereas before we saw presence or absence of these skills, now we're seeing changes in requirements. So SQL was one of the top terms, top 5 terms that came out of this analysis. And this is an analysis that encompasses language as well. It's not just skills. So I looked at SQL demand and as a proportion of all jobs or various other cuts of jobs, and we didn't see much of a difference really in terms of SQL demand. But what we did see, and this is probably the thing that I want you to take away, is that the SQL requirement has actually increased in very specific types of roles. So we're seeing it in FP&A roles. So these are finance roles, in your finance sort of verticals of companies. We're seeing it increase in biz dev roles. So when companies are doing a lot of analysis of their sort of flow, and actually from a HR perspective, we've seen this a lot too. As companies are trying to build out people analytics teams, we're seeing a huge growth in SQL requirements in HR roles. So it has stayed steady in a range of others, but this is sort of showing us shifts, that these verticals that we don't think of typically in terms of data science skills, that you wouldn't necessarily apply to as a data scientist, have got some interesting roles for data analysts particularly, and they've got a very interesting growth sort of trajectory ahead of them. They're sort of very cool. So with that, I know I ran over time. I just wanted to thank you all, and feel free to come up to me or ask me any questions on LinkedIn, Twitter, or anything else, or even in front of everyone. So that would be great. Thank you. Oh, okay, great.
Any questions?
You can take mine. Maybe that one works. Oh yeah, go for it.
Any questions from the audience?
We can just hand this back and forth.
Go grab your
Yeah.
Sure.
Yeah.
Have you seen or have any perspective on sort of the diversity of roles that a data scientist is playing and how that relates to job titles? At least I worked as a consultant and then joined a startup, and we were debating what should my job title be. Should I be a data scientist? Should I be a data engineer? Should I be a machine learning engineer? And quite frankly, at a 4-person company, it just feels like somewhat of an artificial distinction because I'm doing a little bit of everything at a startup. So does it matter in terms of recruiting talent, particularly for a startup, or does it, and like, I imagine that role matters more at a large company, but there seems to be a diverse array of terms that are all sort of in the parent realm of data science. How do you see that playing out, and is it relevant for attracting particular types of candidates?
Yeah. I think that's a great question. I think what we're seeing is we're seeing an expansion of those roles. So like machine learning engineer wasn't really something that was around a couple of years ago in any meaningful way. So I think actually you have two questions. One of which is in most companies, what we're seeing is that data science skills are being taken up by specific verticals, and we're starting to see more data scientists in, like, as in an FP&A or a HR, a people analytics person. So we're actually seeing a diversity of roles that are more analytical in focus, and they're actually requiring data science skills, so modeling as well as biz and things like that. We are seeing expansions in terms of machine learning engineer, like the titles of machine learning engineers. I think they've actually changed though, because I thought one of the things that would come out of this skills analysis was we'd see huge amounts of machine learning and deep learning like as in a growth in that. But we haven't actually seen a growth in that. I think it's changed much more subtly, but I haven't actually looked at the job titles that associate with it. We just looked at the number of skills. It does, I think, we haven't looked at how machine learning, calling something a machine learning engineer versus like a more software engineer role that deals with some machine learning impacts the candidate pool. And that's actually a very interesting question. I should actually take a look at that. But I think those are, it does impact the quality of your candidate pool. One of the things to be wary of and that we're always conscious of is that we want to make sure that you get a broad candidate pool that isn't turned off by the title. So maybe machine learning engineer is becoming a bit more comfortable for a lot more people, but I don't think it used to be for a while. And so it wasn't a very popular term. So those are the sorts of things that we try and tell people, that you should try and be as standard as possible, but be as descriptive so that people know what you're coming into. One of the other areas, I was just talking to someone the other night, is from a software engineering standpoint, there's a lot of roles that are called like software engineer internal tools. And those roles are actually typically very, very much underperformed in all of the analysis that we've done, because no one wants to work for the internal tooling of a company, right? They want to be on the business focus side of things. And so so that's sort of a tension that, you have to at the same time tell someone that that's exactly what you'll be doing, but that it also impacts your candidate pool in a dramatic way. And so we're still trying to figure out what's the best solution to something like that gets to the right point. But yeah, I mean, I call myself a research scientist. We're not a huge group, because I do a bit of data science, but I don't feel like I'm only a data scientist. I do all these other sorts of aspects of research. It's completely arbitrary, and it's very silly to call myself anything really in such a small company. But we do it, and so we can have email signatures and nice slides.
Question over here.
Oh,
hi. I wanted to know if goodness. If there was the number of layers of vetting or the number of interviews in the hiring process had a significant impact on the probability of a successful hire.
Yeah, so the thing that we find is obviously a lot of interviews, so we do count that. A lot of interviews do impact it, but the single biggest impact, one of the big impacts, especially from a candidate perspective, is a long process. So even if you have a lot of little bits to your process, if they're done in a condensed fashion, like within a few weeks, it makes a lot of difference versus something that takes 2 months as a process. Then you get a lot more candidates just pulling out of it. And so we find that actually it's the bigger like stretch of time that impacts a candidate more. They've probably found another job at that point, or decided, you know, this company is moving way too slow for me, like they're not my pace of things. But we do some of that analysis, like we look at assessments and things like that as well, like how are they impacting that process. But that's what we found as on a big problem level, that's the single biggest impact is, you know, from stage to stage, how long it takes. Yeah.
There's a question right here, and then we'll go down there.
Oh, or he can go first.
Okay.
Yeah. Can you talk about how it's possible to kind of take a more holistic approach to hiring a data scientist? Because, you know, in my opinion, it's more about building a product than it is about like taking a reductionist approach. Okay, if you know SQL, if you know Python, if you know sklearn, you know, that makes you a great data scientist. Where it's not like it's a holistic thing.
Yeah.
So what kind of analysis could you do to address that?
So, I mean, we're a little bit opinionated about this stuff. I tend to tell what we try and do is make the bar as low as possible in terms of like stated requirements, but making sure that some of them are required. So like when I have to career counsel data scientists, for example, I'm like, get SQL on your resume. Like no one's asking you to do really complex joins for the most part, but a lot of companies ask for SQL, and that's a huge barrier to, like those requirements act as barriers. So it's a very much a sort of like breaking down the skills into the things that are required, and to get a sense of the growth of that person. So that's a hard thing to explain in a job description, but that intuition can kind of be there. So maybe you don't need SQL, like maybe you don't care if, like you probably do need SQL from a day-to-day basis, but maybe it doesn't need to be in the job description because you know that someone can learn SQL really quickly. It's, you know, someone has a growth mindset and they can learn. So part of that is sort of expressing that you're coming from a growth mindset company, that, you know, you will facilitate people to learn. You know, my data engineer that I work with right now has never dealt with data engineering before. We tend to hire from very unusual fields because I want to see the transfer, and I wanted to, like, as in someone who was really interested in this sort of area and wants to learn. And so his background is a software engineer, back-end software engineer, and so that I think from that standpoint, it was very much a like expressing that we wanted someone who wanted to learn this stuff. And I don't care if you don't have that expertise, but I want to see that you have a history of learning new things. So I think expressing that in a job description, which is a kind of very esoteric, totally abstract thing to express, but it's sort of drilling down the requirements of what you actually need. And I needed someone who could write beautiful code that has unit tests and does all of the right things that it's supposed to, but wants to learn this other area that I think is, you know, like cool and interesting, and he thought it was cool and interesting. The other people thought it was cool and interesting. So it's a little bit about matching both of those things, as to pulling back on requirements in my mind and really trying to express that this is a mindset, this is a growth field. These are things that we will help you do. You know, we will send you to conferences, we'll send you to PD, like find you courses to build up those skill sets and really build you and invest in you. And I think that actually brings out a lot of qualified candidates. Even if they don't need to build those skills, I think there's something that gels about an environment that really values you as a contributor, or that we will set aside 20% of our time to work on open source things or whatever else. Like there's ways and levers that you can pull that communicate a culture that I think are very helpful in terms of a holistic. I hope that answered your question. I'm happy to talk about more specific stuff as well.
Hi. So I've seen personality tests and problem-solving simulations as ways to assess the soft skills of a potential candidate. And I was just wondering what your thoughts were on having these tools combined with AI to potentially eventually replace HR managers. Do you think that's going to happen, or do you think that there's more of an art to seeing if someone's like good at teamwork, for example?
Yeah, I haven't seen the outcomes of a lot of those personality tests and things like that. I know Pymetrics is apparently a really good job of, like, there's a bunch of these sort of companies that do that sort of thing. The one thing that I worry about with tests is the sort of, we don't know how unbiased they are. We don't know how fair they are. There's a lot of companies that won't publish anything on like what they get in versus what they get out. And until we start, I mean, this is me coming from a scientist, as a peer review scientist, to be like, until I see the data, I don't really believe them. So that's one aspect of it. The other aspect of it is, I mean, that's one thing from, like, as in, if you think about technical jobs, like data science jobs, software engineering jobs, you know, we tend to believe a lot in tests and whiteboard interviews and things like that. I'm not sure how predictive they are yet. And so I think that's one aspect of the questions that we really have to, like, as companies, need to invest in and ask those questions. The other side of it is, I'm not sure that those tests will ever replace the soft side of HR or the career document side of HR. And I'm working for a company that's trying to understand career documents. So I should really be worried about tests. But the thing is that the vast majority of jobs are not as technical, can't be, you know, you can't figure out by tests. And as you get more and more senior, the managerial side of things, you can't assess those through tests. That's my personal opinion, right? What you're very curious about seeing, and what I enjoy about career documents, is seeing how someone's developed and the skills that they've developed, not only from an anthropological standpoint or a sociological standpoint, but just from a, like, the person who I want to work with. And that gives me a lot of insights into it. I'm not sure tests can actually ever fully cover that sort of set of things, but I'm very curious to see how they work. Like, this is all still a budding, very interesting ecosystem that's got a lot more to it than it is, than we have seen yet. And so I think we'll see how it bears out, but I still think that career documents, so whether it's job descriptions or your resumes or all the other forms of documents that you put together, and, you know, your promotion packages and various other things, those are still going to play important roles. We're still going to have a lot of soft decisions that we have to figure out ways to de-bias a little bit from our gut instincts. And so I think that that's a really interesting area of research, personally. Obviously I do, because it's where I work. But I think it still hasn't borne out totally. And those are the questions that I'd want to ask them, is that, you know, how accurate are these sorts of soft skills measures? Like, they might give you a number, but, like, how much do you trust that number, and how predictive is it? I don't know.
Great. I think that's all the time we have for questions, but Maryam will be around the rest of the day if you want to grab her and discuss any ideas you might have. So thank you, and thank you, Maryam, for the great presentation.
Thank you.